Hello.
Hi, sorry, we can hear you.
Great. Hi, everyone.
Hi. Hi, Sudalai. My name is GK.
Hi, GK. How are you?
I'm good, thank you. Thanks for this session. We have other folks, Sudalai. Just give us a couple of minutes. There's a large group who is very interested on this session.
Oh, good to know. Yeah, sure. Thanks.
I think we should be able to go ahead and start. So, hey, Sudalai, thank you so much for joining, Sudalai. Appreciate your time. Suri, you want to give an intro for Sudalai to the whole team?
Yeah, sure. Hello, Sudalai.
Oh, hi, Suri.
Hi.
Good afternoon.
Good afternoon. Nice meeting you, and very warm welcome to this session. Sudalai. I'll give a quick intro what I try to capture on the internet and based on our LinkedIn connection, right? So it definitely love to have Sudalai as part of the session. He has a very good experience on AML. He was 3 times Kaggle Grandmaster. That's a great achievement, I would say. Definitely great to have in our session. He been an AML advisor for a lot of startups, and he worked with many good AML organizations like H2O, Freshworks, Tiger Analytics, Global Analytics. Currently, he's heading the AML at Growfin.ai. It's another startup, right? With a mechanical engineer background, I think he done this journey. So definitely, to start with, this as the session says, ask me anything, SRK. So I'll start with one question. Probably I think people have a lot of questions to ask you. So we'll start with the same thing, SRK, is that definitely we understand, we did a good, Kaggle journey. Just, for all of us to understand, right? How did you do your Kaggle as a success journey? Definitely this question would have been asked multiple times to you, but just for our audience sake, I just want to understand, or for the people's sake, how did you make 3 times successfully this grandmaster? And for people who are just to get inside the Kaggle and to want to be successful, give us some good tips and guide. That should be my first question, SRK. Thank you.
Yeah. Thanks a lot, Suri, for the warm welcome, and thanks, GK, as well. And thanks to Bhupalan for inviting me to the session too. So yeah, it's a pleasure meeting you all, firstly. Yeah, great to be here. So Cool. Yeah, coming to the question, right? So yeah, I mean, yeah, that's a great question. So actually, yeah, so when I started working on this data science analytics side, right? So, I mean, say even for now, like for most of the people, we have a lot of courses as well as theories and books and things, right? So, I started learning from some of these MOOC courses, but then like after I found out, so there's a lot of theory that I gain knowledge on, but there is no practical place where I can go and try and implement those things. So that's how I came across Kaggle. Like, I mean, say for people who are new, like Kaggle is a data science platform where there will be like multiple hackathons done on real world data sets by different companies from across the world. So that will help gain a good amount of practical knowledge on solving the AI/ML problems. So for someone who's starting on Kaggle, the very first thing is, okay, so to have some basic idea about machine learning or data science, some basic concepts, understand the basic concepts, and then start working on some of these basic problems. So there are some simple playground problems in Kaggle, like Titanic prediction, where one need to find out, like, say, which people will survive the Titanic, uh, like sink, and there are a few more simple problems to start with. But then the real learning, if you ask me, like that comes mostly when we take part in real competitions where like actual companies push their problem and we try to solve them, because that way the competition will be intense and we'll like work with multiple people from across the world and learn a lot during the process. So as a beginner, one of the thing that will be like, say, oh wow, there are so many people out there, and like there are so much of intense competition going out there, like say, will I be able to like get a good place or do something out of it? So that will be the biggest hindrance. But yeah, I mean that happens, and at times we'll find that, okay, so we are not able to improve much like during the course of the competition as well. So like being there and doing it consistently, like for a period of time. So that is the main thing. So I would say for anyone who is starting, because at the beginning we might feel like this is so huge and like whether I will be able to crack it or not. But so being there and doing that for a good amount of time, so will automatically get us to the success part.
Thank you, SRK. Good.
Okay, sorry, thank you. So, Bhupalan, do you have the agenda? Sudalai, you have the agenda for today?
It's a free flow. Ask me anything kind of session. Okay. We can ask any questions to SRK. He's here.
Oh, excellent. Okay, it's open to all. Great. Okay, I have a question, Sudalai, for all our engineers, data engineers, and data scientists, right? How does someone start their career as a data scientist? I know, people need to do a lot of math, computation. So what do they need to be strong in when they come into data science? How do they set up a career in data science? That's for me also, right? Want to understand what are the basics and how do they progress over a period of time?
Okay, yeah, that's a great question. So yeah, I mean, so as you mentioned, right? So data science being a multifaceted field, right? So it involves a lot of things, say like maths, computer science, and statistics, and so on. So it also depends on the role that you try to enter into, and then like say the career progression over time. So basically, like say if we would like to start something as a data analyst, so then they should be like really good in the basic data analysis, like say data merging with some of the Python packages or something like that, and some really cool visualization. So I mean there are multiple tools. So I would just say like what are the things that are needed. Say data visualization is an important thing, and obviously storytelling is an important part, because like as a business we would like to understand what actually comes out of the visualization, so that we could do some meaningful business impact based on that one. So that's one thing. And then coming to say if you would like to become a data scientist, then I would say like on top of this, so we also would need to learn about the machine learning concepts and the modeling algorithms and so on, so that we could become a good data scientist. Okay, so and then like say there's also this I mean machine learning engineers, so are like full stack data scientist kind of positions where we would also like to know more about the engineering part of the side as well, like in addition to building the models and like we also need to put them into the production, so we need to have a very good understanding of the system, so that like say, we can scale the models to multiple users and do the monitoring system for those models and so on. So it depends on like say whichever position that we are looking into. So probably we'll start with something simple, and then like say we can upskill ourselves and then move on to say data scientist. Once we are like fairly comfortable with being a data scientist, then like learn more about full stack data scientist and go to the next level and so on. So that's how I see a career progression.
It's okay. I have a question, sir. Okay, so I know you would have solved several problems in related to data science, right? Can you quote us one example, which was kind of more satisfying to you? One very interesting problem that you had solved, a business case.
Oh, okay. I mean yeah.
Keep the client names confidential. It's okay. We're just interested in the problem.
Okay, so I mean there are like multiple problems, right? As you mentioned. So some of these, I mean, yeah. So one of the like the time series problem, so which is more like a forecasting use case, right? So that's kind of very interesting. I mean, generally the forecasting time series problems are slightly interesting in the sense it is kind of difficult because I mean not really difficult, meaning we need to find out a right kind of validation sample so that like it actually generalizes well on the out of time sample. So in case of if you're not really generalizing well, right? So due to the seasonality, cyclicity, and things like that, so it takes I mean say it won't perform as well as we expect it to. So once what we did was, so it was a complex problem because like we need to take into account not just the sales, but also depending on like what week of the previous year, and like say similarly we have given like multiple different weightages to multiple different models, so as to come with a like a complex solution that encapsulates all these different aspects into the model building process.
What kind of vertical was that? Which vertical is it?
This is with respect to the e-commerce vertical.
E-commerce, I think.
So yeah, so that is an interesting thing because like we have to build multiple models to capture the multiple different aspects. Say one to capture the seasonality and things like that, and then finally put them all together to come up with the complex solution that encapsulate all of these things together.
Oh, nice.
Yeah,
team, feel free.
I have a question, Saket. So generally, where do you spend more time in your typical ML pipeline? Is it on model architecture selection, or feature selection, or feature extraction, or general data transformation? So how does what is the distribution of your time across all these things?
Yeah, I mean that's a good question, Bhupan. So as the most of the time generally is spent on say the feature creation. I mean feature engineering part, basically like say where we spend more time on actually like I mean looking at the data and then creating some interesting features so that it can be fed into the model building process. So it could be like based on the given data, so create new features based on that one. So that is one thing, or else like we can look into alternative data sources as well. So if there is anything else that is there with the client or with us, so that we can make use of the data and build some more interesting features out of it. So I would say like I mean the actual model building process is probably like 20%. If you would say like if you have to split time between both these two, the feature engineering part takes in the predominance and it is about 80% of the time, while the model building is actually some 20% or so. I mean, and right now, so as you could see, most of these models, we have really good libraries, and like there are super good parameter tuning algorithms as well, so we can make use of them to do these things much, and in general as well, right? So when, at least from my past experience, so please feel free to correct me, or like if you guys have different experience, please let me know as well. Like when we need something like a really good amount of improvement, say if you have something like 70% accuracy, and if you would like to get to 75% accuracy, most of the times, so these kind of accuracies are like being delivered most of the times from the feature, creating new features and feature engineering. So probably like doing hyperparam tuning and trying out a different model most of the times. If you already have a good model, so probably you could increase from 70 to 71, but say something like 70 to 75, most of the times it happens from feature engineering for me.
Okay, thank you. Exactly. So, and how often do you use automatically generated features? Do they help at all in general?
Yeah, so that's a good question. Having also worked on the AutoML space, right, as part of my work. So, yeah, that's a great question. So, yeah, so these AutoML based features, right? So they kind of give a very good baseline. So, with respect to feature engineering, I would say, like at least there are two types of features. So one is the features which we can auto generate some things, like we could create some interaction features, we could create some transformation features automatically, or we could create some say if there is a categorical feature, we could use a label encoding or one-word encoding or some different types of encoding methods, and then use them to build the model. So these are some of the features that can also be automatically created by using some of these AutoML tools. But say that there are also features that are specific to the domain knowledge. Based on our domain knowledge, we'll know that, okay, so the combination of these features will add a good value to the current model. So the AutoML tools are generally able to capture the first type of features, but these domain-based knowledge and the features that are created based on domain knowledge, so like we need to create it on our own and improve the model. So, but AutoML generally gives a very good baseline and gives some very good interaction features and some basic automated features at the start, and then we can add on top of that one.
Okay, thank you. Okay, so I will just leave time for others for now.
Sure.
Yeah. Hi, Sudalai. This is Akilan.
Hi, Akilan.
So my question is like, recently I was reading a lot of blogs. So I came across a small note like, as per the Gardeners by 2025, 70% of the organization will shift to big data, shift from big data to small and wide data. Like, what do you think, or what is your thought process on that?
So by small and wide data, Akilan, can you please bit elaborate on that one, if possible?
Yeah, so basically like currently like a lot of data are generated, but the quality of the data is not actually is very important. So when I say small and wide data, that simply means like I'm talking about the data quality, or the how that will impact the AI model, or what's your thought process on that development side of AI ML model development side?
Okay. Yeah, so that is a good point, meaning like the data quality, right? So in spite of the amount of data being captured, so we definitely need a quality data in order to build our model. So if it is about like capturing quality data, then definitely that is going to be the thing, basically, because yeah, there is no point capturing a lot of data if there is, if you don't have really much information in those like really bigger data sets. So definitely the industry will move towards that, I guess. And also, yeah, so as a general thing, right? So currently, if we look at most of these vision models or NLP models, so we have these multi-billion parameter models, right? So which are really big ones and trained on huge data set. So I think the size of these models will reduce in the upcoming years because, like say, we need very customized hardware, like say GPUs, TPUs to run some of these image NLP models. But I think like with time there will be like more research and like say more improvement. So we have simpler models that can run on mobile devices and so on.
Got it. Got it.
Cool. Thanks.
Like addition to that, what is your thought process on synthetic data? Because like we are building a model, but actually getting a real-time data, it's kind of very difficult. So generating a synthetic data and gimmicking all the patterns, like how is that going to follow in next couple of years? Like will the synthetic data generation or data related pattern which we generally, because like when we create a real-time data, that's a different scenario. But when we create a synthetic data, like we tend to create something which is not existent also. So like with this question, like addition to previous question, I wanted to know what is your thought process on that also.
Synthetic data is something, yeah, so that will be useful, but also we need to be really careful while creating the synthetic data, because like while creating the synthetic data, right? So if it is too close to what we currently have, then like that information is already being captured by the models that we currently build. But say if that data is kind of different from what the current data is, like then there's a chance that that may not represent the actual current representation of the data itself. So it's a I mean, we need to walk a tight line. So this I mean, semi-supervised learning is something that has been like gaining more prominence in the recent days, right? So there are quite a good amount of research that is going on over there. So I mean, at least I would say I haven't seen like really good ways in which we can generate synthetic data currently, but yeah, in the coming years, so we might be able to do that much better. Yeah, something like say we have GANs for like image, right? So we use GANs to create images and try to do some kind of models on top of that. And similarly, like generating synthetic data for the numerical structured data as well. So that would be something that we would get in the future.
So adding to Akhilan's question on synthetic data, Saket. So what is the percentage you would recommend? Generally, if you have a data set and probably if you want to increase the accuracy, what would be the percentage of additional synthetic data based on our existing data you would propose? So I heard your point on being, taking a cautious approach.
Right. Okay, so I mean, say it's a really tough question to answer, to be very honest, because it also depends on how much data we have, right? So if it is 100 data points, so we don't know. Like if it is 10,000 data points, then that's a different answer. But say one thing, right? So at least, I mean, this has also been proven in Kaggle. Is like generally people add like 1 to 2% of the synthetic data, so for some good number of observations. So like say more than 20,000 observations. So something like a 2% of the semi-supervised learning that they will use. So they'll get some data which is very similar. I mean, they'll have data which is very similar to the training data, and then add that to the data set and retrain the model, so that by gaining some performance improvement on top of that one. But I think if we have a bigger data set, then that's going to be a problem. But if you create something like SMOT or something, right? I mean, if that is the synthesis that we are talking about, then that most likely will generate very similar data points to what we already have in the data set. So whether that would add some additional value on top of what we currently have, so that's a question. I mean, we don't know a good answer for that one.
Okay.
So,
okay.
But yeah, do you have any like what type of synthesis is this, image, or is this NLP, or is this structured data? So that also plays a role. Any pointers there, Bhupal?
Yeah, usually, for example, imbalanced data sets, like if we are looking at credit card anomaly detection kind of problems, whenever we're handling, right? We do not have that many anomalies, right? So that's why I was thinking about how much probably we can generate something out of it and then try to feed. But anyways, we need to take a cautious approach there, like you said.
Yeah.
So that's why I wanted to know what would be your usual approach.
Makes sense. Yeah. We need to be a bit cautious over that. I mean, especially with respect to the fraud detection kind of use cases, right? Because that's a slightly trickier one.
Sorry to interrupt. So because we have been just adding to the discussion point, we have been handling some types of problems along the lines of credit card transaction flagging system, or a network prediction system. Whenever there is a network outage kind of problems, we have been handling in the recent past. That's why I want to.
Got it. Yeah. Makes sense. Yeah, if it is very rare, right? Some people even try to do that using the anomaly detection method, right? So something like isolation forest or things like that to do the anomaly detection, especially with respect to the logs and outrages. Yeah, and other thing, which I wanted to add was even this. Currently the like GBM, the XGBoost version of the boosting models also have a class imbalance module built into it, so we can enable that one, and also that tends to perform slightly better compared to the traditional, the common one that we use.
Okay, thank you.
Sure. So on that one, right? So have you also tried something like isolation forest kind of anomaly detection methods as well, or is it more supervised learning, Bhupalan?
So we were trying out with the isolation forest.
Okay.
So, but we are not willfully, but we are just trying out. Probably Suri can also add.
We do a mix of multiple algorithms.
Oh, great, awesome.
Isolation forest, but we tried isolation forest, but it did not give better results actually. So we dropped isolation forest.
Okay.
Sometimes random forest itself is giving a better result than isolation.
Okay. Good.
It's a mix actually. I would not say one algorithm for anomaly detection, and that's when what Akhilan's question is that the challenge is availability of the data, right? That's when we went on creating synthetic data. So trying to generate the data which is required for our AI model to do that. So yeah, thanks for answering the question.
So the synthetic data creation, right? So one way we could do that is after creating the synthetic data, so whichever model that we have built, right? So try to predict using that model that has been built, and say whichever falls in the very top percentile, so we can use that as the synthetic data.
Correct. We're also trying to address the bias in the data, through synthetic data. In our data, knowingly or unknowingly, we'll have a bias in the data, right? So we want to avoid the bias, so that when we do the synthetic data generation, we have to ensure that there is no bias in that, and there are no.
Yeah. As you mentioned, there are so many levers that we need to adjust at the same time to get that thing. Yeah.
Go ahead, Brinda. I want to have a question. Please go ahead, Brinda.
Yes. Hi, sir. This is Brinda here. So my question is that if you are building an AI-based solution, so is it better to use Python or Julia? So which one would be a better option for the future?
Hi, Vinamam. Good afternoon. So always there, right? So these kind of debates are always there, Brinda. So Suri is laughing as well. Probably he would have also had these questions a lot of times here from so many people. So actually, learning about the concept. So that is the main thing. So the tool is just another part we can use to solve the problems. But okay, at least with respect to the current scenario, right? So I mean, when I started, so at least R was the prominent thing with respect to the data science, data analysis at that point of time. So Python was just a programming language, and then like slowly it moved more towards Python. And now I see most of the people using Python. And Julia, so I started hearing at least from some 5-6 years back, like even from that time. So many people are saying that Julia is the next for data science, but at least in the current situation in which I see, like the Python ecosystem is growing up and up and up. So there is a lot of support for all different types of models and algorithms. So, and Julia has a really, I mean, it has to play a catch-up game to do all these things in the environment so that like people start moving towards that one. So yeah, I at least I think probably I might be wrong as well. So for the next 5 years, at least 3 to 5 years, so Python will still be a good language for the data science machine learning. And if at all, like it could be Julia or any other language that has come up with a better ecosystem. So ecosystem plays a very important role. So ecosystem of libraries, packages, then that will catch up with Python. But yeah, I will let add Suri and Gopalan as well on their thoughts.
I think correct. So Python with the recent packages, okay, like what we are hearing, the speed problem is getting addressed, right? With the recent version, that's what Python is claiming, right? People used to claim a problem that Python is always slow one because of all that this thing. With the recent, I think that's what they're trying to claim. Now the speed problem will be addressed in the recent version of the Python. So thanks for answering that.
Thank you.
And along the lines, this recent tool, the PyScript, running Python HTML. What do you think about the future of that set?
I mean, that is good, but it has just started, I think, Gopalan, yeah. So I think they need to make some really good progress so as to be like kind of more universal and like being used in multiple places. But yeah, it's a really good start. So I feel so that will enable like data scientists and machine, I mean, Python practitioners to do like the front end as well easily. But I think that it needs some more maturity to get us there. I mean, that's my personal opinion. So how about, I mean, do you have any views, Gopalan?
No, I honestly didn't know that's how we would actually use that. So from a practitioner's point of view, I wanted to know because you are developing that day in and out. Right? That's right.
Makes sense.
Sudalai, Avinash here. So just have one question on image enhancement side. So I mostly work on the imaging part. So there is one common problem I see with image enhancement segment is that the image quality is mostly evaluated based on the perception of the people, like how they see a particular image. So sometimes it becomes difficult to actually evaluate the image quality and train it based on that, because let's suppose if there is a photographer, if he sees an image, he will try, let's suppose there is a model which removes noise or maybe the compression artifact from an image. What he will see is like whether the fidelity of image is maintained in the result or not. But when it comes to a normal person like us or maybe some other random person, what they will try to say is that enhancement means like the color is looking good or not, or the edges are sharp or not in that sense. So it becomes quite a difficult to give a generalized form of model or a result which will be like liked by most of the people, not everybody. So how do you what do you think, like how should be this image quality should be evaluated in a better manner?
Okay, so as you mentioned, right, it's highly subjective, meaning like say what is good for one person is not good for the other person, right? So okay, yeah, I don't really know like is there a better answer. I mean, it depends on like which type of people are we is our target customer, maybe that. I mean, so this I don't think this could be solved more from the data science standpoint, but from the getting the business side. So we could see like which kind of people would be the end users for this particular application. If it is more of professionals, then we create that based on that one, or if it is more of the normal people who would be using it mostly, then the answer would be, let's say we create more shortcuts, kind of things like that. So, I mean, there is no, like say, data science way in which we could solve it for all different types of customers. Maybe we need to use the camera to find out what type of person that that our girl is, and then like work on.
Yeah,
But
so
yeah,
right
so
now that's the way we are doing it. So we ended up having like 10 different models for 10 different scenarios. So that, yeah.
Yeah, probably we can ask them like, yeah, what the professional, then based on that one, so use the model. So,
All right. Thank you.
Yeah, thanks.
Yeah, Sudalai, Akhilan here again.
Hi, Glenn, yeah.
So, previously, or maybe like a decade back, machine learning techniques were very popular, but now the industry is shifting towards deep learning and like working on NLP techniques, working on transformers, BERT models, and like computer vision techniques. So this transition, how does the data like is still machine learning techniques really into practice, or like it is overtaken by a deep learning techniques? That's my question, because mostly deep learning, all the techniques, those are pretty advanced technique, but still the data, we are generating a lot of amount of data, and then complexity increases, data variety increases. Still, is there any use of machine learning techniques, or we have the industry has shifted completely to deep learning techniques? Just your thought process onto that.
Got it. Definitely. Yeah, okay. So yeah, so I think when you mention machine learning techniques, you mean more of the models that are outside of the neural network based models, and deep learning is more neural network models, right? So okay, got it. Sure. So yeah, as you mentioned, right? So like I mean, the industry is still using both the types of techniques. It depends on what type of problem they are currently solving. So like with respect, I mean, when it comes to more structured data problems, right? So where we need to deal with the numerical or categorical data. So the machine learning techniques still plays a very important. I mean, they give much better results compared to the deep learning models most of the times, and so that is being used a lot in the industry. So the reason we are hearing more about this thing is like in the initial days, so it's mostly like I mean, the whole industry is solving only the structured data problem. So I mean, and most of the ML models were being used. So now most of these problems are solved, and like most of these models are also put into production so as to do the predictions and so on. So the industry people also started solving problems in the other data, like image data, NLP data, and so on. So and as more, I mean, as people started solving the image NLP problems as well, so there's a huge amount of influx of deep learning people. I mean, the skill that is also needed for the industry. In say what I see is like this is something that will keep on moving. So after 2-3 years, so now if everything is image and the NLP is done, so people will start doing the multimodal learning problem. So where putting all these things together, like image, NLP, and structured data to come up with to build models, and then like now as you also notice, so there's a lot of interest in the graph, NNSRP graph scale databases as well, where currently we are just saving the attributes, right? So with respect to graphs, so we also save the relationship as well. So how we can make use of these relationships in addition to the attributes to build better models on top of that one. So so that's how I see the industry evolve. But so to answer your question, so yes, the both ML and DL models are being used in the industry. When it comes to structured data, it is mostly ML based models, and when it comes to unstructured data, the DL based models are being used a lot.
Yeah, actually, like my follow-up question was regarding the graph ML, like how graph technology is evolving into, like how machine learning graph theories are coming into that. But yeah, you answered that.
Okay, good to know. Thanks.
Hi, Sudalai, this is Megha.
Hi, Megha.
Hi. So we received a couple of questions internally and I've just collated it together. I'll go one by one.
Sure.
So the first question is having a very good GPU hardware the only way to train models in our own machines? Do we need to invest in expensive machines?
Okay, so yeah, that's a great question actually. Yeah, so that's a tricky one. I mean, basically, if you would like to learn and more about and compete more in the same image or the NLP based problems, right? So using a GPU or a TPU is kind of becomes a must now. So probably a few years back it was not, but currently, like most of the unstructured problems are being solved with using, I mean, deep learning models, so which can be run in local machines, but say it takes like probably days to complete. So using a GPU or TPU is preferred. But having said that, right? So yeah, at least these machines cost a lot. I mean, not just to buy and also to maintain. Like say, even the electricity cost will be high. So I mean, in case if there is some hardships in getting that machine, so I'd suggest like say, I mean, Kaggle, like open source platforms also give a lot of GPU or TPU compute. So for example, Kaggle, like we get around 30 hours of GPU compute and 20 hours of TPU compute per week. So which we can make use of to learn. So these techniques, and also Google Colab is again available. So where we also get some amount of GPU compute as well. So at least to start with, so we could use these free resources to learn more about all these techniques, and then like say to work on some problem, so that needs a lot of GPU or TPU compute. I mean, most likely then we can put in money to get those things. Yeah.
Okay, thanks. And the next question is, which model is your favorite for tabular data? Everyone is talking about XGBoost is all you need, etc.
Okay. Is that the end of the question, Megha? Is that right?
Yes.
Okay, good. Yeah, so that's again, yeah, XGBoost is one of the most famous algorithm or like widely popular algorithm for the structured data. So I would say, I mean, the flavor of gradient boosting in general. So it could be XGBoost or Light GBM or Cat Boost. So I mean, when we have tried like multiple, at least in the Kaggles in multiple different problem sets or multiple different challenges. So these gradient boosting algorithms have given much better results compared to other YAML-based algorithms in most of these data sets. So the XGBoost or Light GPM or Cat Boost is my general go-to algorithm when it comes to tabular data sets.
Okay, so okay. Yeah, and the next question. What kind of tools or editors do you use for data transformation tasks?
So in, I mean, say like the editors with respect to the coding part. So generally for Python, right? So I used to use PyCharm, but now I use Visual Studio most of the times. And then with respect to the data transformation, most of the times, yeah, I mean the general suspects like pandas most of the time. So do that on smaller data set, but say if we have to do it on a bigger data set, so we do use Spark for data processing.
Yeah, I think in general, people were curious to know the technology stack that you usually work with. Circuit. So, for example, productionizing a model. So, what kind of data transformation editors or tools that you usually put into place while taking a model into production? That's how I understood it.
Got it. Okay. Makes sense. Okay, so that's right. I mean, editors in the sense of PyCharm Visual Studio kind of editors, right? So writing.
So technology stack in terms of what are the tools you generally use? Do you work with cloud tools or in solving a model, deploying a model?
Okay. Yeah. So basically, like say, so for I mean, say most of the times currently we are working on the cloud-based environment. So we do use some kind of a version control like GitHub, GitLab, Bitbucket to put the codes, and say most of the times we use Docker-based, I mean, some kind of containers. So something like a Docker, so that we have the same kind of environment in the production systems as well, and then like say if it is an API based environment, right? So I mean say Flask, Fast API something. I mean Flask used to be the thing, and Fast API is something that is kind of easy for a Python based data scientist or a machine learning engineer. So we could use the Fast API and use I mean expose that as an API so that like the other people can use it. Or if when it comes to say data orchestration, so then something like the Prefect or Daxter. So these are currently two most I mean say similar to Airflow, so which is more like scheduling and orchestrate. I mean scheduling the task. So if you have to run it at a given point of time, or like say based on some conditions, so then these are some of the tools that is being used. And say with respect to the monitoring part, so most I mean say the experiment tracking kind of part, so YAML4 is one tool that that's being used so to track the experiments and see how the experiments compare with each other and so on. Yeah, so these are some of the tools that we use, and depending on the cloud provider, right? So if it is GCP, use BigQuery, or if it is Amazon, use Redshift and kind of things. Does that answer, Gopalan, or is there any specific place that you are looking at? Yeah.
No, that answers the question. Thank you very much.
And if you have any specific area that you are looking at, probably yeah, that's also something.
Yeah, that's pretty much about it from my side.
Sure, yeah.
One question from my end, Surya. So now that most of the cloud providers provided AML services, correct? Azure or AWS are providing, and in some of the customer places, the question that we get is like, anyway, they're coming with all the services, right? So from the data scientist point of view, like, what is that, value add that we can provide on top of that? Because if you want to go with, the Azure services, cognitive services, anything, they're like a plug and play, correct? What will be the role of data scientists in that per se? When say that, there is a kind of an autonomous solution, ready-made, it's all available, like, just drag and drop, right? So what will be the role of a data scientist in that per se? Like, what else he could do more than what, a cloud services, provides as part of AML services?
That's a great question. So actually, yeah, everything, right? So overall, the ecosystem will keep developing, and let's say as a person, I mean, as people, like we also need to upskill ourselves, like every now and then. So okay, so having said that, so these kind of things, right? So these kind of things are pre-trained models, or like say the models that they have trained on their own ecosystem. So mostly, like when starting, say something like an AML or a data science thing, then like say we don't have any, I mean, most of the companies won't have any data or anything to build the models on. So they, I mean, it's good to use these services as such. But as it matures, right? So most of the time, say, I mean, they provide all these services, but say if you have to use that for multiple hundreds of requests, the amount that will go to their cloud service will be like really huge. So that, I mean, say then like they will slowly move towards to the in-house, where we'll also build the same thing. So that is one thing. And also I see that like most of the times the results that coming out of it won't suffice. So it could be a good baseline to start with. But whatever the business needs, for our I mean, for our business will be like more. So because that being a generic model, it won't fit for all the use cases. So we need to build our own in-house models that gives better results for our data. So these are a couple of areas that I see. But yeah, but anyhow, moving forward, most of these common problems, at least we will have some generic solution to start with. So we won't start from zero. Like we'll have that basic question, and like and as a data science or machine learning people, like we also need to have good skills so that we beat those benchmarks. Yeah,
absolutely, correct. Thank you.
Thanks. Yeah.
If no question, then maybe I'll ask one more question. Anyway, that the black box problem, right, is okay, like for all the customers, like, still, I would say that become a bigger challenge from, from supplier partner point of view whenever we go to customers. Sometimes AML is not a need of the hour, right? It may be, I would say, like, should have, not like, must have kind of a future, right? With that sense, the bigger challenge what we see is people don't get confidence on the model we build, correct? We all talk a lot of jargons, we talk, and then, and it's like a magic, we show some results, right? The challenge definitely, explain a and something are all coming up, but still, from your experience point of view, definitely would have faced such a situation. How do you think we could address such a, a common man problem from the customer point of view? You understand business, but he doesn't even understand, like, what is going to impact my business, what will happen when can I move to roll out to production, because things are all fine, like, but when I say that can I go live, that's when, like, people are like very panic. They do not want to roll out anything, because one of our example, what I see is we developed a reinforcement learning agent, right? And then we are almost to roll out to production, but people are not confident because it's fully autonomous, right? The agent could do actions on behalf of humans. Very less human intervention, but people are not confident. Because of that, the project failed and people doesn't want to roll out, right? So with your experience, how do you think you want to address this problem so that it gives more confidence to the customer and make him understand that, yes, it will definitely support him, not otherwise?
Correct. Makes sense. Yeah, that's a really tough problem. So yeah, and well articulated, sir. So yeah, so one thing, couple of ways to say, like, so generally, I mean, it start small and then go big is what we could do for such kind of people, because like for someone who is really new to this kind of environment, right? So if we kind of use a gradient boosting or reinforcement learning, so it will be fast for them. So first introducing them to like say something like linear regression and decision trees, where they can see like which variables are impacting, and like say decision trees meaning showing them the trees. Okay, so if it is this way, it's good. It's more like the rules, right? And then like say once they gain confidence and putting them into production, like say after 4 or 5 months, they will understand the business value add due to that one. So and we will also gain some confidence in the meantime, so that like say they would be okay with what we build after that one. So that is one thing. But say of course, like for us even to look at the reinforcement learning or things like that. So probably we could use some of these tools like Shap, or even we can like build a parent-child kind of model where we build a decision tree with outputs of the complex model and show the rules so that they gain confidence. Okay, so this is what is going to happen, and like these kind of things. I mean, in addition to these things, right? So having a very good monitoring system as well, like in place, so that will give them confidence. So they'll tell them, okay, so this will be continuously monitored automatically. So something goes off, so it will be automatically triggered, and we'll get to know. So rather than looking after 3 months and figuring out that it's not going to work. So having both of them in place, like, will be helpful to run this.
Okay. Thank you, sir.
Yeah, thanks a lot. So, yeah.
That's it from mine. Bhupal, anything else, Bhupal, from mine?
Yeah, I'm pretty much done. Actually, we can ask hundreds of questions to Saki, but
nice. So are you all based off Coimbatore, Bangalore? Like,
it's a mix of Chennai and Coimbatore, predominantly Coimbatore. I'm from Chennai, okay. So.
Okay. Good to know. Yeah.
And we have offices in Bangalore and one coming up in Hyderabad as well.
Oh, very nice. Cool. Yeah, great. So yeah, Bangalore is a really nice city. Yeah, I studied in Bangalore, so yeah.
Okay.
Cool then. Yeah. Anything?
I think no, it was. I think if there are no questions, SRK. So it was nice talking. The session was very useful. I would say, patiently, like listening to your questions. Like some of the questions may be very basic to your level, but taking your time in your busy schedule, SRK. So really thank you. Like behalf of Payoda. So thanks for taking your time. Coming here and then answering all of our questions. Like when Bhupalan said. Ask anything, right? It was definitely like it's a very tough call to take from the answering point of it, right? People say like questioning is very easy, right? Answering is what difficult, correct? So that way I would say appreciate like all your effort, Sarke, in your busy schedule, taking your questions and answering each of that, like it was very helpful. People in our crowd definitely makes it very productive. Thanks for all your time, Sarke.
Oh, thanks a lot, Suri, Bhupal, and Murthy, sir, everyone for inviting me. So it's a pleasure, like say, meeting all of you. So yeah, please feel free to ping me anytime for anything. Sure. So I'll be happy to answer. Yeah.
Definitely. Thank you.
Thank you very much.
Thanks a lot, everyone. Yeah, bye. Have a great day.
Bye. Thank you.
Thank you, everyone. Thank you, Sudalai, for your.
Thank you.
Thank you.